Welcome back to this video lecture series on data structure and algorithms. Today we'll be talking on one of the most important operations operated on a graph data structure, that is the breadth first search. So let's start. So first what we need to know is that if we want to traverse a graph, there are two most common methods. One is the breadth first search, another is the depth first search. So when we are talking about the BFS or the breadth first search, here, we first visit the vertex and then visit all the vertices adjacent to the starting vertex. Next, we pick the adjacent vertices one after another and visit their adjacent vertices, and this process goes on and on until we reach the last vertex. One thing to remember, whenever we do this traversal, each node is visited only once. So if we take up this example, suppose this is the graph we have, and also this is the graph we will be using for the programming example. So now let's say we want to start the BFS traversal from the node or the vertex 0. So the strategy is first visit all the adjacent nodes of that starting vertex and then again do the same. So if this is the starting vertex, and as we can see 3, 4 and 1 are the adjacent vertices, so first the visited nodes will be 0, 1, 3, 4. Now then take this vertex. What are the adjacent nodes? 2 and 4. Now 4 has already been visited, so 2 will be visited. Now let's come up to this 4. The adjacent vertices are 1, 0, 3, 5, 7, uh, again 1, 0, 3, 6, 7, 5. As we know and as we can see 1, 0, 3 they are already been visited. 6 is yet to be visited, so 6 will be visited, 7 will be visited, and also 5 will be visited as it is also the adjacent node. Now if we come to 3, then we will see all the adjacent nodes have been visited. So again it goes on forward. So again if we come up to these nodes, like 2, 6, 5, 7, these are the nodes or the vertices which have recently been visited. We can see that only for the vertex 7 this adjacent node is yet to be visited. So we visit this one, and this is the last vertex to visit. So this will be the right uh, breadth first traversal of this graph. So let's now go to the programming part and see how we can implement it. So I have opened my IDE, and what we are going to do is we are going to do this breadth first traversal. So for this program, I'll be needing the help of the queue data structure. For that, I have already defined the important functions and the variables we'll be needing here. The insert queue, the is empty, and the delete queue. So in the main function, we will operate mainly two important functions. The first function is the create graph function, and the next function is the uh, binary breadth first traversal. So for that I'll be needing some global variables to declare. Before that, again I'll be needing this macro definition. So first will be initial. It will be having a value of 1. Now I am doing this because this will help me to keep a track on the state of a node, whether it's been visited or not. So I'm defining 3 states here. One is initial, next is waiting, and the value will be 2, and lastly with the value 3 the last state will be visited. Now the global variables we are talking first will be the n, that is the number of vertices. I'll be needing an adjacency matrix, so this is it, a 2D, sorry, this will be a 2D, sir. matrix, and I'll be needing another, you know, a state matrix. I'll be actually using three functions here, so let me just declare it. The first function is a void return type, the create graph function. The next one will be the breadth first traversal, and another one will be needing, that will be the actual BFS. It will have a integer argument. So let's start with this create graph function. So I'll be taking some variables here. First will be the count, then the maximum number of edges possible, an origin for an edge, and the destination. So first what I'm going to do is I'm going to have a count on the maximum number of edges possible, and that will simply be n into n minus 1. Now I'll say that enter the edges, or rather enter the adjacent matrix. So for that I'll be initiating with this count value 1, and this will run for max edge number of times and simply count plus plus. So I'm going to first print down a message that says enter %d edge and a message -1 to quit. So for the first iteration it will say enter the edge 1, and what I'm going to do is I'm going to take the value these will be stored in origin and destination. Right, now I'll have to before making an edge I'll have to check for some conditions. If I see that the value of origin is -1 or the value of destination is -1, then I'll simply break. Another condition is that if I get to see that, or let's give it an else if, that the value of origin is greater than the number of the vertices. Okay, before that here actually I just forgot it. We have to mention that enter the number of vertices, and we're going to take %d a value of %n. Here also this will be %origin and %test. So coming back to this condition here, if this is the condition, or test is greater than n, or origin is less than 0, or test is less than 0, then what we do is we print a message that's invalid entry, and what we do, we decrement the count. Otherwise, if this is not the case, then we take this adjacency matrix, the origin and the destination, and we give it a value of 1, which indicates that an edge has been created. So this is the logic for creating a graph. Now what we will be doing is we will be defining this BF traversal. So for that, the return type will be this BF traversal. So I'll be taking a variable v here. Now what I have to do is, for all the vertices, I have to assign them with the initial state. So I'll run a loop here. V is equals to 0, v less than n, the number of vertices, v plus plus, and what I simply do is state of v will be given a value of initial. Now what I do is I ask the print the user actually that enter the starting vertex, and I take the value in this v variable, and I simply do is I call this BFS. You can see that I have already declared this function BFS. So now let me just define this BFS function. So int v. I'll be taking in a variable here. So here the first thing to do is the state of v now will be waiting, because it's the starting stage. And before doing it, what we're going to do is we're going to insert q here. I'll be doing this only. Now the state is waiting here. Now I will run a while loop here. So while not is empty, that is the queue is not empty, we will be running a loop. So we'll first pop out the value of the queue, and we'll say that state of the view is now visited. Now I'll check if an edge actually exists. So if the adjacent of v and I is equals to 1, and if I get to see that the state of the destination vertex is still the initial, then only what I can do is I can insert this destination vertex in the queue, and I can actually make the state of this vertex as waiting. Okay, so one thing to do here is, for this part here I'll be running actually a for loop. So I just mistook it. So I'll be starting up with this I value of 0. This will run for the number of vertices we have, and this. right? So let me just copy it. Here it is. Okay, I just need to do a bit of indentation here, right? Okay, and one thing, here we can actually print down the message, the nodes or the vertices we are visiting. So we can say visited vertex percentage d, a new line and a v, right? So the while loop is terminated here. So let's now run this program and have a check on the output. Okay, so here's the output terminal. So we will be taking the example of this graph. So if you can see that there are 9 nodes or 9 vertices, so the number of vertices will be 9. Now the instruction is to enter the adjacent matrix. So what I'm going to do while for entering the edges, I'll be starting with one vertex, and then we'll go serial like 0 1 2 3 4 5, and there will be no repetition of any edge, like these are only one directional edges. So starting with the 0 vertex, there's an edge between 0 and 1, then 0 and 4, then 0 and 3. Next, node 1. Now 1 to 0, like there's this node but it's already been covered, so this and this edge is yet to be done. So 1 2 1 4. Now coming to the vertex 2, 2 1 is already done, 2 5 is yet to be done. Next, vertex 3, 3 0 is covered, 3 4, then 3 6. Then coming to vertex 4, so 4 1 is done, 4 0 is also covered, 4 3 is also covered, 4 6, then 4 7, then 4 5. Then coming to vertex 5, 2 5 is covered, 4 5 is covered, but 5 7 is not covered, so 5 7. Then anything else for 5? No. And 6, 6 3 is covered, 6 4 is covered, 6 7, nothing is left for vertex 6. Coming to the vertex 7, only one connection is to be done, because as we can see 4 7 is done, that is 7 4, 7 5, 7 6, so only the 7 8. And as we can see, if I go to the vertex 8, there is no edge, so I can quit now. So -1 -1. Now they will ask me for the starting vertex from which I will start the BFS. So I'll be starting up with the 0 vertex, and here is the output of the breadth first search. As we can see, the traversal has been done exactly and properly. 0 1 3 4. So this starting vertex, then the adjacent 1 4 3, then 2 6 5 7, 2 adjacent to 1, 5 adjacent to 4, 6 adjacent to 3, 7 adjacent to 4, and lastly the 8 that is adjacent to 7. So the BFS has been executed properly. Thank you for watching this video and staying with us. See you next time.